The hunt for extraterrestrial life involves several key assumptions: that life is based on carbon, aliens would be dependent on water, and that the planet's temperature would have to be within the Goldilocks zone. Hi everyone, Vega here, and in today's video we're going to be looking at another alternative, where a planet is not in the Goldilocks zone and doesn't even indeed have a parent star. Let's talk about rogue planets. The Nancy Grace Roman or Wide Field Infrared Telescope, when it's launched, could reveal that our Milky Way is teeming with billions of orphan planets without a star. Our hypothesis is that life could evolve on them, and it may just be that we could use them as stepping stones to the stars ourselves. The first step is to establish how far does the influence of the Sun really begin. In this video we will imagine arbitrarily that as we see here, there are 3 rogue planets in between here and Proxima Centauri, our nearest star at some 4.22 light years. The first planet, as we see, is housed within the Oort cloud on the left. In many ways this could be classed as part of our own solar system, with 2 more planets separating the gulf between ourselves and the Proxima sister. The first of our worlds is actually a twin system, with a parent moon orbiting. As we can see here, the gravity of the 2 bodies pulls, twists and scrunches each other, creating friction and heat in the centre of the objects. Internal dynamo means that heat erupts on the lava as a surface. It could replenish the lost atmospheres, very similar to Jupiter's moon, Io. This type of planet, a lava world, while it may be warm enough, unfortunately, would likely be very unstable as it constantly replenishes its surface to reform. It would be difficult for us to colonise, although the bodies could be used to orbit around, or indeed for raw materials. The body within the Oort cloud in the future would not be so far as that we could not visit within a lifetime, especially given the improvements in technologies. The chances of a rogue planet being exactly in the line of sight between us and a distant star is small, but so far in our observations of 50 million stars, we've observed 474 incidents of what is known, as we see here, as microlensing, where the gravity of a body twists the light coming round, revealing the body in between. It's thought that as many as 10 of these 474 incidents briefly revealed what could have been Jovian mass or even less sized worlds. In October 2020, Ogle 216 BLG 1928, yes that really is its name, an Earth mass rogue planet, was discovered by pure chance in the Milky Way. Our next world is an ice ball world, frozen solid in the depths of space. This kind of world on the surface might seem extremely inhospitable, but it could have warm ocean currents circling inside itself, kept warm by geothermal vents emanating from the nuclear decay that could still be happening in the core. The decay could last for billions of years, keeping the planet inside its warm. It could even be there in some areas in the surface where warm waters could survive, replenishing maybe an atmosphere of water vapour, and with no solar wind for it to restrict, maybe it could even rain. If hope remains of finding life on Jupiter's moon Europa, then why not another world like this one? Europa itself is far enough from the Sun that it's barely heated anyway. There are many other dark bodies within the limits of our solar system. When you think of places like Triton or Sedna, maybe Makemake, where the Sun's influence really is negligible. Who's to say that these worlds themselves are not captured rogue planets and could have originally been just like this one? The further we look, further we find other worlds like far out, and indeed far, far out. We may not be able to see rogue planets per se, but this in itself is not evidence that they exist. Triton, for example, orbits backwards and does not appear to be a native of the Neptunian system. Our next world is perhaps the most interesting of all, a fully habitable world, way outside of the habitable zones of any stars we know of. It's interestingly because the possibility of a small Earth-like or even possibly a Mars-sized planet having a thick atmosphere becomes a much more realistic possibility once we take away the danger of solar wind. Indeed, with nothing else to pull on, light elements like helium or hydrogen, we could have very thick atmospheres of those elements that would shelter and harbour the surface from dangerous radiation, and indeed, like a greenhouse, keep the surface much warmer than it would be otherwise. Possibilities also of different types of life may also exist. So far in our solar system we have barely even fully explored one other world outside our own, and that would be Mars. On Mars we've found no evidence of life so far, but different types of life forms cannot be ruled out, and that includes perhaps non-carbon based life. or a life form that indeed requires less heat and light to survive? What would it mean for Nancy's Great Roman Telescope if it found rogue planets in our galaxy, even in our universe between the galaxies, to be plentiful? Could these worlds, along with black holes and other invisible heavy objects, be dark matter? I think we could probably rule that out, as we must take into consideration that even thousands upon thousands of these worlds would still not really be remotely as heavy as a star or even a heavy brown dwarf world. Indeed, studies have estimated that there could be as many as 250 to the ratio of rogue planets to planets that are actually in star systems. And again, once we consider places like Sedna, Makemake, or even Triton, is it beyond the realms of possibility that there may just be an endless supply of these worlds roaming the dark cosmos forever? If this is the case, they could be used to our advantage. We could use them as stepping stones between the stars. We could refuel and regroup and reorganize on these places as we jet off further into the deep, to places like Alpha Centauri and beyond. Even within our own lifetimes, these places could be reached, but they do have to be found first, of course. Maybe we could reach these worlds, then we could take them apart, mining precious minerals, the building of perhaps O'Neill cylinders, or even Battlestar Galactica-like convoys. Do you think there are thousands of rogue worlds out there? My gut feeling is that, like for each star, there may be many giant planets. For each giant world, there are probably many terrestrial worlds. And so, for each terrestrial world within a solar system, maybe there are hundreds, thousands, or maybe even millions of rogue planets without a name wandering the cosmos that one day will become a home for the human race. Thanks for watching. Don't forget to check out our other videos. We've just started a new extra solar planets series where we can talk about Proxima b and C, or the possibility of a planet on Alpha Centauri A, also known of course as Ridge of Taurus. Don't forget to like and share and subscribe if you enjoy this kind of content, as it does help the channel grow. Stay safe in these difficult times, and I'll see you on the next one.